Hello everyone, my name is Siddharth Kannan. I am a first year student from Sri Venkateswara College of Engineering, and today we will be talking about vector calculus and linear algebra. Gradient of a scalar field. The gradient of a scalar field function is denoted by del f, or where del, the nabla symbol, denotes the vector differential operator del. The notation grade of f is also commonly used for the gradient. The gradient of f is defined as the unique vector field whose dot product with any vector v at each point x is the directional derivative of f along v. That is, del f of x dot v is equal to dv of f of x. In three-dimensional Cartesian coordinate system, it is denoted by the following. Physical interpretation Physical interpretation of gradient. One is given in terms of the graph of some function z is equal to f of x comma y, where f is a reasonable function, say with continuous first partial derivatives. In this case, we can think of the graph as a surface whose points have variable heights over the xy plane. An illustration is given below. If, say, we place a marble at some point x, y on this graph with zero initial force, its motion will trace out a path on the surface and it will choose the direction of the steepest descent. This direction of steepest descent is given by the negative of the gradient of f. One takes the negative direction because the height is decreasing rather than increasing. Using the language of vector fields, we may restate this as follows. For the given function f of x, y, gravitational force defines a vector field f over the corresponding surface z is equal to f of x, and the initial velocity of an object at a point x, y is given mathematically by del f of x, y. The gradient also describes directions of maximum change in other contexts. For example, if we think of f as describing the temperature at a point x, y, then the gradient gives the direction in which the temperature is increasing most rapidly. Curl. In vector calculus, the curl is a vector operator that describes the infinitesimal rotation of a three-dimensional object vector field. At every point in that field, the curl of that point is represented by a vector. The attributes of this vector, length and direction, categorize the rotation at that point. The direction of the curl is the axis of rotation, as determined by the right hand rule, and the magnitude of the curl is the magnitude of that rotation. The definition. The curl of a vector field f is another vector defined as the following determinant. It is also defined as the following equation. Points to be noted. If curl f is equal to 0, then f is called an irrotational vector. If f is irrotational, then there exists a scalar point function phi such that f is equal to del phi, where phi is called the scalar potential of f. The work done in moving an object from point P to point Q in an irrotational field is phi of upper limit Q and lower limit P, which is equal to phi of Q minus phi of P. The curl signifies the angular velocity or rotation of the body. Divergence. In vector calculus, divergence is a vector operator that measures the magnitude of a vector field source or sink at a given point in terms of a signified scalar. More technically, the divergence represents the volume density of the outward flux of a vector field from an infinitesimal volume around a given point. If f is equal to p into I plus q into j plus r into k is a vector field on del p by del x, del q by del y, and del r by del z exists, The divergence of f is the function of three variables, which is defined by divergence of f is equal to del p by del x plus del q by del y plus del r by del z. In terms of the gradient operator, del is equal to del by del x of I plus del by del y of j plus del by del z plus k, del by del z of k. The divergence of f can be written symbolically as the dot product of and f, del and f. Divergence of f is equal to del dot f. We have now come to the end of the video. Please like and subscribe, and thank you.